Hello, my friends. I'm Clover, and this puzzle is called 6 by 9, and this is Philip Newman's 42nd birthday puzzle. So Philip turned 42 the other day, and this is an arrow Sudoku that he posted in Gas on July 29th, 2024 to celebrate that occasion. Happy birthday, Philip. So we have normal Sudoku rules. So we're placing the digits 1 through 9 once each in each row, each column, and each outlined 3 by 3 region. In addition, we have arrow Sudoku rules, so each of these arrows, the digits along the arrow itself, sum to whatever number is in the attached circle. So for example, in this case, the attached circle contains a 2, so our two digits along the arrow have to both be 1s to sum to 2. To make a sum of 4, we have to do either 2 and 2, which is impossible in this case because 2 sees both of those cells, or 1 and 3, which is how we're going to complete it. 4 with both of the cells being in the same region has to be 1 and 3 again. These are also going to be 1 and 3. And I believe that is all of the arrows in the puzzle where the small digits are in the circle. These 2s are going to place a 2, and this 2 here are going to place a 2 into this cell. These 4s plus these two 4s are going to place a 4 here, and I believe that at this point we've placed all of the 2s and 4s in the entire puzzle. So where does that leave us? We have some arrows that have 4s on them. This circle will be 4 plus something. The something can't be 1, 2, or 4, so it must be either 3 or 5 for a total of 7 or 9. Here, this 4 has to be summed with 1, 3, or 5 for a total of 5, 7, or 9. Now this is where the puzzle got a bit tricky for me, but let's persevere. There are, I think, 2 kind of more complex steps than usual in this puzzle, so let's walk through them. This isn't one of them, this is just placing a digit that I totally forgot to tell you about. So here we have 2 3s, that places a 3 here and gives us a 5. So, what is our next move here? Okay, so we have 3s here. They see these cells in region 2, which means that 3 in region 2 has to go into one of these 2 cells. That tells us that 3 is already placed in row 2. It's got to go here or here, therefore it can't go here. So that can't be a 3, that must be a 5, making this cell a 9. I'm going to fill out some pencil marks here because next I'm going to illustrate to you something that happens with 9s here. So here, this can't be a 1, 2, 3, 4, or 5, so this must be a 6 or 7, making this an 8 or a 9. Okay, now if you look at 1s and 3s in rows 2 and 3, we have a 1 and 3 in row 3, and then we have a 1 and a 3 in one of 2 cells in row 2. So in region 3, 1 and 3 can't go in any of these cells that I'm highlighting now, and they can't go here because this is the bulb of a fairly large arrow. So 1 and 3 have to go in these cells. And now here's the next interesting step. 9 in region 3 can't go in these cells, so it goes in one of these 2. We can eliminate 9 from here, that eliminates 5 there. And then also, because we now have 9s in column 7 and column 9, they see all of these cells in region 9, so we're going to place a 9 right there. And that is really what we need to get started. So if we look at column 8, we have 1, 3 pair, 2, 4, and 9. So that leaves us 5, 6, 7, and 8 that we still need. That places a 1, 3 pair here. And now if we look at this 5, 6, 7, 8, these cells out of those 4 have to be the ones that contain the 6 and the 8, because 6 and 8 can't go here. So because we know we have a 6 and 8 in these cells, that will be a 7, which makes that a 9. These cells will now be a 6-8 pair. The 7 eliminates 7 from these cells and places a 7 here, which makes this a 3 and resolves our 1-3 pair. These digits are now going to be 1, 5, 6, and 8 in some order. And these digits are going to be 6, 7, and 8. Now because this is 6, 7, or 8, this has to be whatever number sums with 2 to make that total, so it's 4, 5, or 6. And it can't be a 4 or a 5 because it sees those, so that's a 6, making this an 8. And that's going to place a 7 in this region and also resolve this 6-8 pair. The 5 and 6 here make this a 1. Now let's finish off a little bit more of this row. So in this row we need 7, 8, and 9. And also in this row right below it we still need a 3, which can only go into that cell. And here we need 5, 6, and 8, but we can't place a 5 there because of the 5 in the region. So the 5 goes over here and that resolves the 5, 6 pair. This can't be an 8. In fact, these two cells have to be a 7, 9 pair. Now this 3 is going to place a 3 up here. These two 6s will work together to place a 6 in this region. This will have to be a 9. This will be a 9 also in the row. 6 in the region will go here. These will be 5, 7, and 8. That 9 resolves this 7, 9 pair. The 6 resolves this 6, 8 pair. And that's going to be a 5 with a 7, 8 pair adjacent to it. The 7 reduces this to an 8, 9 pair. These will be 1, 5, and 7 to finish the row. The 1 has to go there because of the 1s in these columns. If we look vertically here, these will be 5, 7, and 8. This is the number that gets summed with a 2 here. So it can't be 8 because those would sum to 10. Can't be 7 because we can't place a 9 here with the 9 right here. So that's going to be a 5, making this a 7, which resolves that to an 8. The 1 in the row resolves this 1, 3 pair. That's not an 8. This is a 5 or a 6, and because there's a 6 in the column, we know which one it is. The 5 here will resolve this pair. These guys are going to be 6 and 9, which resolves quickly. And I think we're just about finished. So the 7 resolves this pair, making this an 8. And these are going to be 7 and 9, like this. And there we are. That's how you solve Philip Newman's birthday puzzle, 6 by 9. Hope you enjoyed that one. If you want to give it a go yourself, the link is in the description immediately below this video. Enjoy, and I will see you next time.